In disaster zones, mining sites, and massive construction projects, one machine often appears first: the bulldozer. At first glance, it looks slow, heavy, and simple. But what makes bulldozers truly incredible is something almost impossible to believe. Some bulldozers can push debris weighing nearly 100 times more than the machine itself. So how is that even possible? How can a machine weighing around 40 tons move mountains of dirt, broken concrete, rocks, and steel that seem far beyond its own size? The answer lies in a combination of physics, engineering, traction, and raw mechanical power. And once you understand what's happening underneath the metal body, you realize a bulldozer is less like a truck, and more like a moving fortress built to overpower the ground itself. To understand bulldozers, we first need to understand the environment they work in. Most vehicles are designed for speed and efficiency on roads. Bulldozers are designed for the exact opposite. They are built for environments where normal vehicles completely fail. Loose soil, mud, collapsed buildings, steep terrain, massive piles of rubble. In these conditions, wheels become almost useless. Tires spin. Vehicles sink. Engines overheat. But bulldozers keep moving. That's because instead of wheels, bulldozers use continuous steel tracks. These tracks spread the machine's enormous weight across a much larger surface area. Instead of sinking into soft ground, the bulldozer floats over it while maintaining incredible grip. This grip is the secret to its pushing power. A bulldozer does not rely mainly on speed. It relies on traction. The more traction it has against the ground, the more force it can transfer into the debris in front of it. Think of trying to push a heavy object while standing on ice. Your feet slip. Now imagine pushing while standing firmly on rough concrete. Suddenly, you can apply much more force. Bulldozers operate on the same principle, but on an enormous scale. The tracks bite into the terrain like giant metal claws, allowing the machine to push unbelievable loads without losing grip. But traction alone is not enough. The real heart of the bulldozer is its engine and transmission system. Modern bulldozers use extremely high-torque diesel engines. Torque is the twisting force that allows the machine to move heavy resistance at low speeds. Unlike sports cars that focus on high speed, bulldozers are optimized for slow, unstoppable force. Some of the world's largest bulldozers produce over 1,000 horsepower. But horsepower alone doesn't explain their power. What matters more is how that power is delivered. Bulldozers use special transmissions and gear reductions that multiply force dramatically before it reaches the tracks. This is similar to using a low gear on a bicycle when climbing a steep hill. You move slower, but with much greater pushing power. Inside the bulldozer, giant gears reduce speed while multiplying torque thousands of times. The result is a machine capable of applying incredible force continuously for hours. And then there's the blade. The massive steel blade at the front is carefully engineered to control and direct enormous amounts of material. At first glance, it may look like just a giant metal wall. But its curved shape is extremely important. As the bulldozer pushes forward, the blade causes dirt, rocks, and debris to roll upward instead of simply piling straight ahead. This rolling motion reduces resistance and allows the machine to move much larger volumes efficiently. Engineers have spent decades refining blade designs for different environments. Some blades are wide for moving large amounts of soil. Others are narrow and reinforced for rocky terrain. In mining operations, bulldozers may push giant boulders weighing several tons each. And during disasters, they clear collapsed concrete, twisted metal, and broken structures after earthquakes or explosions. But one of the most surprising things about bulldozers is that they rarely push an entire load all at once. Instead, the debris moves gradually. As the machine advances, friction and gravity constantly redistribute the material. The bulldozer is not lifting 100 times its weight directly. It is continuously overcoming resistance little by little while using momentum, traction, and blade geometry to keep the material moving. This allows it to influence masses far larger than the machine itself. Another reason bulldozers are so powerful is their weight. Some of the largest models weigh more than military tanks. That weight pushes the tracks harder into the ground, increasing friction and grip. In physics, friction is what prevents slipping. More downward force means more potential pushing force. In simple terms, the heavier the bulldozer, the harder it can push without sliding backward. And modern bulldozers use advanced hydraulic systems to control every movement with incredible precision. Hydraulics use pressurized oil to generate massive forces. When the operator raises or angles the blade, hydraulic cylinders can exert thousands of pounds of force smoothly and reliably. Without hydraulics, controlling such enormous loads would be nearly impossible. Some bulldozers now even use GPS systems and onboard computers to automate grading operations with centimeter-level accuracy. What once required years of operator experience can now be partially controlled by intelligent systems that calculate terrain in real time. But despite all the technology, bulldozers remain extremely dangerous machines. The forces involved are enormous. Tracks can crush concrete. Blades can move entire vehicles. And on unstable terrain, operators face constant risks from landslides, collapsing debris, or rollovers. That's why bulldozers are built with reinforced steel frames, rollover protection systems, and armored cabins. Some are even remotely operated in hazardous environments like minefields or radioactive disaster zones. And perhaps the most incredible thing is that bulldozers are not designed for elegance, they are designed for survival. Every component is oversized. Massive steel frames. Thick hydraulic cylinders. Gigantic engines. Heavy-duty tracks. These machines are expected to operate in dust storms, extreme heat, freezing temperatures, and terrain that destroys ordinary vehicles. So when you see a bulldozer slowly pushing a mountain of debris that appears far too heavy to move, remember what's actually happening underneath. Gigantic diesel engines producing relentless torque. Steel tracks gripping the earth with crushing force. Precision-engineered blades controlling the flow of material. Hydraulic systems multiplying power through pressurized fluid. And the laws of physics working together to transform a slow-moving machine into one of the strongest land vehicles ever built. Because bulldozers don't win through speed. They win through unstoppable force.
Thanks for watching. Don't forget to like, share and subscribe for more amazing videos, and turn on the bell so you never miss an upload.